input and another resistance, and this is connected to ground. Look at this ratio here, 2.7 mega, and this is 220. So the amplification here is very high. It's 2.7 mega divided by 220. If you calculate this is extremely high, very high value, because it's mega, like time 2.7 times 1 million. Okay, uh, let me calculate how much it is. 2.7 times 1 million divided by 220 equal, yeah, 12,000, approximately 12,000. 12,000 times. So the signal here will be amplified 12,000 times. So even there is a very small signal here that comes from the reflection of the light from the light emitting diode to the phototransistor. If there is any small signal, it will be highly amplified here, and the output here will run the light emitting diode. Okay, you guys are going to simplify this, sorry, to simulate this, but you are not able to simulate. I cannot simulate this with PSpice. That's why I'm going to replace all this with something. I'm going to show it to you in a little bit. Okay. So now let me explain the project of tomorrow. We will do it with PSpice today, and tomorrow we will do it with Suddenly. Okay. So let me tell you, if you have here these two resistance here, let me have 10 volt here. If you bring your multimeter to measure the volt, and this is 1K, and this is 1K, what is the voltage between these 2 points? Hmm? 0.14. The voltage, you bring your multimeter, put the red here, the black, the dark here, and this is ground. And you have a battery here, 10 volt.
Close to 8, or
Is it 5 millivolts?
No. You are measuring the voltage across the battery. This is 10 volt. What you will get? You will get 10 volt also. You will get 10 volt. Yeah, because you have a voltage difference here of 10 volt applied to whatever, if it doesn't matter. But actually, you are measuring the voltage across the battery, which is 10 volt. So if you bring your multimeter and put it like this, you'll get 10 volt. If this is 1K and this is 1K, and you bring the multimeter, measure the voltage here and the voltage here, what you will get? You have 1K here and 1K here. We had this multiple times before. 0.7. 0.7, this, if there is a diode, you can say 0.7. But 0.7, don't mention it if there is no diode. So you have two battery, sorry, two resistance, 1K and 1K, and the total voltage is 10 volt. So what will be the voltage here and the voltage here? You said something? 5 volt. Yes, this is 5, because the voltage will be distributed. When you have resistance in series, the voltage is distributed, so that you have V1. Okay, let us say you have R1 here, so you have V1 here, R2 here, V2 here. This V1 or V2 is the voltage across the resistance. You have 5 and 5 because, and the total is 10. 5 here and 5 here, and the total is 10. Okay.
Let's say if it's 2K.
Yeah, we said this before because, okay, let me show it to you. Okay, if you have 2K here and 1K here, and the two resistors are connected in series, what does it mean? The current is the same, right? If the current is the same, this means that the voltage drop here, what's the voltage drop? V equal Ri, right? V here equal R times the current I. This resistance times the current, this resistance. If this is double this, so the voltage here across this one will be double this voltage, right? So if the total is 10, and this double this, so it will be like 6.6 here and 3.3 here. And the voltage is proportional to the resistor. When you have resistance in series, the voltage is distributed according to the resistance value. Okay. Okay, let me remove this. Okay, so I have this. I'm going to extend this here. Another two resistance. You have 1K here, 1K here. And the voltage between these 2 points is 5 volt, and the voltage between these 2 points is 5 volt. What if you bring your multimeter and you connect it like this? This is your multimeter. The black here or the red here, sorry, and the other terminal is here. What will be the measurement here? What it will measure? So this, with respect to ground, the voltage here with respect to ground is 5. The voltage here with respect to ground is 10. So here is 5. The voltage here with respect to ground is 5. The voltage here with respect to ground is 10. The voltage difference from here to here 5. The voltage difference from here to here 5. From here to here 5. From here to here 5. What will be the voltage from this to this? The voltage difference. Zero, exactly 0. Okay, so you are put the multimeter between 2 points, and here the voltage is 5 with respect to ground, and here is 5 with respect to ground, so no voltage difference. So if you put a resistance here like this, there's no current. There's no current will pass. You can simulate this and check. Okay, so here I equal to 0 because the voltage equal to 0. Okay. So let me show you the application I want to do. So let me write this here. And here is operational amplifier, okay? And this is the voltage here. And we have here positive here and negative here. The positive, I'm gonna connect it to this point. The negative, I'm gonna connect it to this point. This is connected to ground, and this is connected to ground. Okay, and here is the output, and I can connect the output to light emitting diode and a resistor and the ground. I can connect this to this. If it is ground, that's fine. Okay, so let me assume we have 1K here, 1K here, 1K here, and 2K here. What do you think is the output? Will the output be high or low? Okay. So I'm assuming I have a battery here, and this battery is like 10-volt battery or something. It's connected to this 10-volt battery.
Is it not inverted?
Okay, let me return back to this page here, the first page. So where it is, not this here. Oh, 1 second. For comparator, if you use the operational amplifier as a comparator, no negative feedback, no resistor here, nothing. Only the operational amplifier itself. If the voltage at this point is greater than the voltage at this point, the output will be high. So if you have light emitting diode with resistor here, it will lit. Okay, but if the voltage here is a little bit less than here, or V negative is higher than V positive, the output will be low and the diode will not lit. Okay, so let me apply this concept to this circuit here. Where it is, yes. Okay, so I have this level here is 10 volt with respect to ground. So this point has a voltage 5. This point, does it has voltage 5 or higher than 5? I have 1K here and 2K here. So the voltage will be distributed so that the higher resistance will take the higher voltage. So what will be the voltage here? It will be 6.6 volt. So I have 5 volt here, and so 5, yeah. So the output now, as this situation, output will be low. Output is low. If the output is low, the light emitting diode will not turn on. Okay. If something happened, okay, so let me think of this. If this is a light dependent resistor or photoresistor, okay? If it is photoresistor or something like thermistor, I'm gonna give you thermistor today to check it. Thermistor is a resistance that its resistance decrease with temperature. Okay, so if this is decreased to 0.9 K, something happened and the resistance here decreased. So the voltage here, what will happen to this voltage here? We have two resistance here, but this resistance is lower than this. So the voltage between these 2 points will be lower than 5. So this will be, the voltage here will be higher than this voltage, and this will be high. And the light emitting diode will lit. Okay. So there are many applications about this. So this could be light detector that detects light if it is low. When it receives light, its resistance will decrease and the output will be high. Okay. Or it could be thermistor, and if the temperature, so the thermistor used to detect the temperature of a container or anything. So if its resistance decreased to a certain level, it has to be controlled with this, okay, adjusted with this. So the output will be high, indicating that there's temperature reach a specific value. Okay, so let me show you this with PSpice. We have here, I assigned yesterday lab week 4, lab 1. So can you guys open it? let me show it to you here. I'm going to take a screenshot and save image, copy image. Can I put it here? Control V. Oh, I cannot. No. Okay. Okay, so we are going to simulate this. So here I use the operation amplifier as a comparator. Okay. So I have these two resistance here. This resistance and this resistance are exactly equal. Okay, 15K and 15K. And I applied here, the voltage here is 9 volt. This means that the voltage at this point with respect to ground is 4.5, right? Because I have 15K and 15K. So the two equal resistance, and you apply 9 volt. So you divide the voltage by 2. Okay. So I have here on this side here, I have 30 here. Forget about this for now. I have 30 and I have 15K. So the voltage here is something like 2/3 of 9 volt. So the voltage here will be 6 volt. Okay. So what will happen now? I have 4.5 and 6 here. What would be the output? This is higher than this. The output will be high. Okay. So at the negative input, I have higher voltage than this volt. So I have here high voltage. Okay. So what will happen when I connect another resistance in parallel with this? So the total resistance here will decrease because I connect 5 in parallel with 30K. So when you have two resistance, one is 5 and the other one is 30. The total is lower than have two resistance in parallel. Less than 5. So when you have less than 5, the voltage here will drop to something like less than 3 volt here. So this will be, when you connect this, when this get connected here, so the voltage here becomes 3 volt. So I have this is lower than this. So the voltage here will be 0. Okay. So it starts high and then becomes low. If you want to reverse the process, connect this to this and connect this to this. Reverse the process. We will do it. Okay. So let us build this with PSpice right now. We have everything. Make sure to put 2 seconds here. Okay. We are going to use transient simulation for 4 seconds. 4S. You just write 4 and the maximum step size 1 milli, 1 M. Okay. And let us see what will happen to the voltage here. So you guys have this in the classroom. So if you like to take a picture now, because I'm going to build this, I'm going to show it to you while building. I'm going to remove this. Okay, so let me here this one. Oops. Okay. I'm gonna close everything. Close. Yes. Close. Or I can save it or close or save it. Yes, or then I will start new one. CIS. New project. Week 4, lab 1. Okay. Create blank project. I will start from left to right. I will start with the battery. So VDC, I'm gonna put the battery here like this. Okay, I'm gonna zoom in. Then I will put the LM, operation amplifier LM741. Here you go. I'm gonna put it here. Then I have the resistors. I need 1, 2, 3, 4, 5, 6 resistors. Okay. R. So 1, 2, 3, 4, 5, 6 resistor here. Okay, I need a switch. So SW to get the switch. So I'm almost done with this. So I need to connect this to this one here. Connect this to this, this to this, this to this, and this to this, 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 this to. Okay, so this doesn't matter. Okay, so I'm going to connect the positive. It will be connected to this side. The negative, it will be connected to this side. And I need a light emitting diode. You can just go here and write light. You will get it. Rotate it. Rotate it so that it will be forward. So you can put it like this. Then you will connect this to this. This resistance is 30K. This is 15K. This one is 5K. And this will close after 2 seconds. It's important to remember this, to make it after 2 seconds. Because before 2 seconds, so from the beginning of simulation until 2 seconds, the resistance here is 30. After 2 seconds, another resistance will be in parallel with this, so it will reduce the voltage here. Okay. So I forgot now to connect this source here, this to this, and this to ground. So the operation amplifier need power. I think I am almost ready. I am missing something. Anybody know what I am missing? Ground, yes, ground. I will take this here, connected here. This is
What's the
ground.
name of that value there? Is it just EY?
Just light, yeah. Write light in the search and take the first one.
You also have it connected right there on top of R5. I don't know. In the picture it doesn't show that. I don't know if
Which one?
R5.
R5.
30.
R5 is 30K.
You have it connected from there to the.
I connected. This is here. It's this connection here from here to this here. So do you mean? Oh, right. Yeah, I connect both two inputs to the same point. This is my mistake. It's a mistake. Extra credit for you. Connect this to this. Yeah. This is okay, ground 1K, 15, 15, 35. Okay. So if I connect this to this, after simulation, I will discover that there is a problem. Okay. So the simulation will be PSpice, new simulation profile. I'm going to use transient simulation. For how long? For 4 seconds. 4, and this is 1M. Simulation, transient time, 4 seconds, 1M. Apply, okay. So I need to measure the voltage here, or you can measure the current, no problem. You can put a probe to measure the current. Okay, I can measure the current here. Yeah, it is not happy. Let me do it here. Yes. So this will measure the current, okay? Let me run the simulation and see what will happen. Okay. So I just want to make sure everybody is able to do this.
What's stuck on the diamond? What do we?
You write here light, you see, in the search, LIGHT, and take the first one.
the settings again?
The setting is here. Four seconds and maximum step size 1 milli. So you're supposed to get this as the output here, not this one. Okay. So you get current as the beginning from 0 to 2 seconds. There is a current through the diode, so the diode will lit. After 2 seconds, the diode will turn off.
Mine's the opposite way around.
Okay. The opposite way around, how do you connect this to this one and this to this? Because it depends how you connect these 2 points and the values you choose here. Okay. So I can do this. I can delete this. I will check what you have now, but I will delete this and I will connect this one to this one and this one to this one. If I do it like this and run the simulation, it will be off at the beginning. Light emitting diode is off at the beginning, then it will turn on. So it depends how you connect the light emitting diode. So how you connect the input of the operation amplifier. Because the operation amplifier detects the voltages and see which is higher than which, and it generates output depending on the 2 voltages. Let me see what you have the same issue?
Yeah.
Okay. Remember, when you have dot here, this means that you have short circuit input. So it's important to delete the lines and take it. Make sure there is no dot. You have the same issue here. Okay. So it's important that when you have no dot here, like this one, if there is no dot like this means that these 2 wires are not electrically connected. It's over each other, but not electrically connected. So everybody is able to get this chart here. Like no voltage, then there is a voltage, or there is voltage, or there is current, and then no current.
Yes.
Okay. So let me ask you an important question. So this light emitting diode, now it will lit for certain time and not lit for other time. From where it gets the power? Who deliver the power to the operation amplifier, to the light emitting diode from this circuit here?
transistor?
No transistor. We don't have transistor. You mean operation amplifier?
Oh, yeah.
Yeah, the op amp. This device here, the output of this device is powering the light emitting diode. Okay,
What is that called again?
operation amplifier,
The operational.
op amp.
Okay.
Yeah, it's very common. Op amp, op amp. Okay. So it's getting the power from the op amp. Light emitting diode needs only like 20 milliampere to turn on. Okay. So can you guys search for what is the maximum output current for 741 op amp? Let me write it to you. Maximum max output current for 741 op amp. Tell me what's the value. Just Google it, you get the answer.
On the PSpice or in general?
No. In general, on Google. Google it.
Volts.
Yeah.
Hmm?
14 volts.
No, current. I'm asking about current.
Milliamps to 45 milliamps.
10, say 10 milliamp to 45 milliamps. So on average, like 25, 30, something like this.
25.
Yeah. So this is okay for light emitting diode. Okay. But if you have, and this is in electrical engineering, the coming concept is really important. If you have a motor, 10 watt motor, okay, and it run with, let us say 10 volt. Let me make it simple in calculations. So 10 watt, it's a motor, okay. If you connect 10 volt here, it will rotate, okay. So what will be the current here? How much current the motor will get? So there's a relationship between the power, which is the watt, V and I. You might have studied this in AC/DC. The power equal to V times I, right? So the motor is 10 watt. This is 10.
Those 10 times 10?
So no, this is 10 here. The power is 10 equal, the voltage is 10 times I. What is the value of I? 1 ampere. 1 ampere. So if you connect a motor now here, if you connect, instead of this, you connect a motor, will it run? Even if it will give 10 volt, like you can change this battery voltage here to 10 volt. Will it run or not? The motor needs 1 ampere, but the maximum current we can get from the operation amplifier is maximum like 20 milliampere, 25, 30 milliampere. But we need 1,000 milliampere. 1,000 milliampere equal 1 ampere. We need 1,000 milliampere. So we cannot use the operation amplifier to run a motor, right? We cannot put a motor here and depend on what will happen here. The motor will run on and off. Okay. So what we can do is the second part of this lab here. Let me show it to you. I'm going to take a screenshot here. Where it is? Okay. So this is what we are going to simulate. So the motor, what we can do, the motor need high current. Okay. What I'm gonna do, this is a motor, I will connect it to the power supply, and I will connect a transistor here. The transistor itself, it has to be power transistor because there will be one ampere will pass through this, so it has to be power transistor. Not the transistor you used in the, not this one here. This is not a power transistor, like 2N3904. No, it is not power transistor. The power transistor looks like this. It has to be connected to heat sink, and it looks like this. It's a big one and need to be connected to heat sink. So what will happen is I'm going to get this current from the operational amplifier, the current that will open and close the switch, the transistor from the operational amplifier. So this is like switch here, but the motor will get the power from the power supply itself, and this is ground here. So the current here, the output from the operational amplifier will close this or open this. Okay, and the motor will get power from the power supply, but the operational amplifier only control the on and off. It will control turning on the power supply, sorry, turning on the motor or turning off the motor through this switch. Okay, so the power doesn't directly come from the operation amplifier, but the operation amplifier, the current, because it's too low, it's used only to turn on and off the switch. Okay, and the motor gets power from the DC power supply. So let me show you this on here. So the output power from this point here. So this is the same circuit like before, exactly the same. Everything is the same. But this represents a motor. It has a resistance 9 ohm, and the voltage is 9 volts. So if you divide this by this, if this switch is closed, if you divide 9 volt divided by 9 ohm, you'll get 1 ampere. Okay, so here, this output here have some current, and it doesn't need this transistor here. Is a special kind of transistor. We studied this before. It's called Darlington pair. Like it's two transistors together, usually power transistor, okay? And because of the very high amplification of this transistor, it needs very little current, very little current. Okay? That's why I connect here 10K, because I don't need much. A little current from here is enough. Okay. So when the output voltage here is high, it will give enough current here. It will close this switch and current will pass. So let us see what will happen when we run this. This is really important. So the previous one, this is an assignment. You guys need to take a screenshot of what you did for the first one and a screenshot of what you will do with this one, and you send it to the assignment. Okay. So make sure don't delete what you did already. Take a screenshot and save it.
Do you want a screenshot showing like the current or just
Both, like take a picture of what the schematic and take a picture of the simulation output and keep it, and then let us build this also. Okay. So this will be, you will modify the other one. If you like to keep it and build another one, that's okay. If you want to modify it, but first take a picture of the what you do first. Okay, so I'm gonna remove this now, and what you are going to do is 10K TIB 122 and 9 ohm resistor here. Okay. Let me see this here. It is the same circuit. This is the same circuit here. I don't need this now. I'm going to delete this part here. Okay. So I need the Darlington pair. It's called TIB 122. It is here. I'm going to put it here. Connected to ground. I need 2 resistance R. I'm going to put one here. This is high resistance, 10K resistance. And I'm going to put another one here. I need to rotate it. This is this one represents the motor. That's why its resistance is low resistance. The motor has low resistance in general. Okay. So I'm going to connect this to this, this to this. Okay. So we are going to use the same simulation profile, and I will use current probe. I'm going to put it here to measure the current. That's it. And you can run the simulation. Everything is the same. The simulation profile is the same. The rest of the circuit is the same. Okay. So here you see the current is 0 up to 2 seconds. Then the current reach almost 1 ampere. Here you have 1 ampere here. It's 0.9, a little bit less than 1 ampere, but it's okay. So if you have a motor in this place, it should work. So in the schematic, I put this here and the other one put it here. It would be the same. It like, so either the motor work from 0 to 2 or the motor work from 2 to 4. It doesn't matter.
Can you check this out real quick?
Yes.
Oh, okay, that's fine. I'm trying to figure out why.
4 seconds.
So the second that one simply delete these two and put the other.
That was just 4.
Okay, perfect.
Wait, what happened? Yeah, this graph is too slow. Oh wait, you put the
So everybody got this.
That transistor or the resistor, you have R8 up there, is that just 9 ohms?
9 ohms, yeah. I make it low to represent the motor. The motor has low resistance. So I just want high current to be delivered to this resistor.
So do the current marker again?
This represent, yeah, current marker, you can put it here. And this represents a motor here. This R8 here represents a motor.
How come it says 10K for the resistor on the,
Yeah, but it still work. But if you make it, because okay, let me explain this. Even if you deliver too much current here, no problem. But if you put 10K here, this will also work, because to close this switch here, if you need like 1 milliampere, if you apply 2 milli, it's still closed. 3 milli, like doesn't matter. But if you make it too low, you might damage this transistor. Okay, so let me run the simulation again, and it will be the same. Here, 0 current here, and here like 0.9 ampere.
mine's backwards.
Backward, it's if this connection, if this is connected to this and this connected, so that's fine. It's okay.
Can I see the other part?
This part here
How come mine is in milliamps?
is still in milliamp. Okay, if it's milliamp, double check this. Is this 9K or 9? Just 9.
Just 9.
Okay, then I need to check. You still have the same issue. Pretty correct. It cannot be. When you connect this, you need to connect to come to this point, then go directly. Stop here.
Yeah.
We shouldn't have a dot here. If we have a dot, this means that you have short circuit here. So now if you run this here, you will get totally different.
Thank you.
Okay, guys, let us take 15 minutes break. Then we come back after break.
You want the same pictures of this second?
Yeah,
picture?
the schematic, also the